So the mutate function is one of the most useful functions in dplyr. So I use this quite. So the mutate function creates new variables. It's as simple as that. So instead of, in this case, if you would have to put new.dataframe, a $, and then new.var in order to create this var times 100. You might be saying that the syntax to do this particular to create this new variable is pretty simple. So why would you not want to do that? In this case, the reason not to do it is the chaining. So say after original df, I wanted to then select my variables, then I don't have to use 2 separate lines of code to do that. So often I'll do the base R option, and then I'll realize 5 minutes later that I really needed to chain, and then I'll end up going back to dplyr anyway. So that's why I use it in almost all cases. The great thing about mutate is the ifelse function and the case when function, which work very similar to SQL for the SQL users out there. So this greatly simplifies things that you have to do in a very complicated way in R. And I'll show you what that looks like in a second. But this is the real basic structure. Again, and I'm sure you're seeing by now that they all look very similar. And the most basic structure that can be used is usually used. So we have our original data frame, and then we are adding to this original data frame this new var variable, which equals var times 100, and then it's dumping that entire result into new.dataframe. So if we go in here, this is something that I do quite frequently. In a lot of cases, when our data is pulled, it's in proportions. But if I'm, say, graphing the values, or passing results onto stakeholders, they're going to expect whole numbers. So that's what I'm doing here. So first, and I wanted to show you another chaining example. So our retirement.dataframe, we have this select function here. We're also pulling state and anything that ends with 2017. So you'll see in here that I have a ton of variables, but say we're only interested in 2017. We can then use this ends with function. And then it will dump these variables into our mutate function. So the census gives you proportions. And in this case, actually these particular ones, I pulled the population total. And then you can see that these are also population totals, just for the sake of showing you how to use this. So in this case, we're finding that proportion. So population greater than 65 divided by the population total, and then we're multiplying it by 100. So I'm going to run that and just show you with the head function what our result looks like. So these are the variables that end with 2017, and then we also pulled these individual, and it shows our population greater than 2017, our population total, and then it shows the result of this operator that has been dumped into % greater than 60. So that is how the most basic way that you would use the mutate function. And so new variable creation. And one thing to keep in mind, and this will make more sense in a minute, when you use mutate, it always adds a new variable, but it keeps the same structure of your original data set. So that's something to keep in mind. And it will look something like this. Are there any questions? So this is the best way to recode variables with another variable. So just for reference, in a lot of cases, the best way to say sort in to set multiple if-else functions in R, base R, you would have to use if-else and then var, and then you would have to then put another if-else statement, and then you would put var, and then 1, and then 2, and then you would have to say, do something like this. This is extremely difficult to read, and it's just clunky, and there's no reason to do this when you have dplyr. You do not have to nest these. So I'll show more about that in a second. So if we go back in here, this is showing how to use the dplyr if-else function. So you'll notice that there is a syntax difference between the base R and the if-else. So you'll see that this if underscore else is used for the dplyr function. You'll want to use that instead, or it won't have the same functionality. So it does not look like this. So, but it works in the same way. It's just simplified. The syntax looks very similar. So we always would use this inside the mutate function, because if else would create a new variable based on other variables. So when we got to these more complicated topics, I like to color code what the description of what's occurring with the value that is shown down here. So you'll see here that I'm telling you that you first insert a logical rule, and that's colored in purple. So we now see, go down here, and we'll see that an example of a logical rule is values over 5. And say in this case you wanted to set true if that logical statement was true, and you wanted to set if you wanted to set greater than 5 if it was true. I apologize. So when this logical value is true, it will insert greater than 5. So that's what the second argument is. So if this evaluates as true, this argument will be used. If it evaluates as false, this argument will be used. So you want to use if else when you only have 2 options. Case when, just similar to SQL, is when you have more than one option that you want to use. And in base R, case when would be when you would have to nest. I'm going to go over that next. Are there any questions about this? Because it is a little clunky looking and more difficult to understand. Okay, I'm going to show what that looks like. So I'm actually going to show the case when first, because this does include that in the code that I'm going to demonstrate. So I tried to do something that looked like something I would do in real life. So I'll go over case when again the next times. So if this would do the same thing as nesting if else R statements. So we would want to use case when we basically wanted to set 3 different values or more. If you had 2 values, you would use the if else. So just similar to what was shown before, it's a little bit different. So each individual line will be a rule. So the first line is values less than 5. Then you use this tilde, and then you set those quotes equal to low. So what this is showing here in this case when statement, our first argument, the logical statement is values greater than 5, and then it's setting any values values less than 5, and it's setting any values less than 5 equal to low. Each one of these rules will be separated by a comma. I'm showing here the correct, or it will evaluate the same way. But to make dplyr functions a lot easier to read, this is what it's going to look like. And say I press enter when I'm on this line, R will automatically move it to this position. So R helps you out there. It will indent after each individual. So if you start with an original data frame, it will then indent your next function. So you don't really have to think about it but I wouldn't change the way that it's written because they do that. So for readability purposes. So the next thing that I'm showing, the next rule, so after the comma, is values greater than or equal to 5 and values less than or equal to 10. So, and then we would have our tilde after the second rule, and then we would put medium. And then we would have our comma, and we would go on to the next rule, values greater than 10. We have our tilde, and that's equal to high. So that's there's one other thing that I need to show, but that is the basic syntax here. So this is very important and something that I got very frustrated when I was trying to decode when I first started using this. So in a lot of cases, you'll want to use those 3 rules like we just showed, but in some cases, you'll want to set everything that doesn't equal these 3 rules to a value. So it's just as we saw in our last piece of code, it's evaluating each one of these rules. So in this case, if all of these rules are false, it's going to default to the next line. So in order to do this, and this is a little complicated, so please ask questions if you're confused, but this is saying this is the same thing as an else statement. So it's basically setting everything that doesn't equal these as true by default, and I want it to be an NA value, so that if these 3 aren't true, that it sets it to NA. This is the part that I got very frustrated with, and I wanted to make sure I mentioned because it really was annoying, and I couldn't figure out what was wrong when I first started using this. So you have to, if you're putting in an NA value, you have to change it to a character variable for it to work with this particular set of rules, because all of these are character variables. So this has to be a character variable as well. I'm going to show this in action. And I'm gonna screw that last step up in the second one just to show you what occurs. So this is a lot more complicated, but this looks more like something I would do in real life when I was coding. So I wanted to show something that looked more like a real life situation. So in this case, I'm selecting to the particular variables, county, state, FIPS, a percent on food stamps, percent with public insurance, so that means Medicaid, between 19 to 64, the percent on public insurance, i.e. Medicaid that are children, and then the unemployment percent. So first I'm substituting to those variables, and I am adding comments between each of these to show you when you say you want to go back and study this, that'll be there. So you'll see here, as I showed you, when I press enter, I'm just going to do that. You can see my cursor is right here. So R automatically indents like we just talked about. So for readability purposes. And in the select function, if you have a lot of different things that you're selecting, you would want to press enter here, and then it will automatically indent to this part. So you don't have to worry about that, thankfully. So this next part, I set the median value up here, so the median percent of food stamps, and then I also set the 33rd percentile and 66th percentile for our unemployment percents. So I'm going to show you what that looks like. We have our median food stamps. The median is 13% being on food stamps in our entire census 2011 data set. The next one is the percent unemployment. So in this case, I'm wanting to split into low, medium, high down here. So that's why I chose the 33rd percentile and the 66th percentile, because I wanted it to be as close to equal groups as possible. Of course, it's not going to be exact because there will be ties. But if I print this, you'll see that the 33rd percentile is 3.8, and the 66th percentile is 5.0 for our unemployment percent. And this in particular, I believe, is 2017. Those are the numbers that are showing. And honestly, I should have put that in my variable just so I would remember that this is 2017. So that would be good practice. What I did up here is not. So the first, and I, in this case, am going to set 2 different mutate statements. So when you want to create more than one variable, write the entire piece of code for one variable and then put a comma, and then you can start the next one. So just as I showed in our code, I am ifelse statement. My logical statement is that if the percent on food stamps is greater than the median, we will have set a high, and then if it's less than or equal to the median, it will be set as low. And I'm also creating a case 1 variable. So in this case, we have the unemployment percent, anything that's less than the percent unemployed. So just for those of you who don't have a ton of indexing experience, it's pulling this first value in the percent unemployment, which is 3.8. The reason you wouldn't hard code this is if you changed or subsetted or fixed anything in a data set that in the quantiles, the result from this changed. So the 33rd percentile, for instance, changed. If you printed 3.8 down here instead of using that ending, then you would have to go back and change it by hand, which is not good practice. So that's something that you would want to do in real life. Try never ever to hard code anything if you can find a way around it, because when you work on data science projects, 99% of the time your data is going to change before you, or your method's going to change before you get to the end of the project. My first iteration of my code is never correct. People review it, I review it, data changes, we update things, and we do not want to have hard coding in that case. So as I showed here, we're using that case 1 variable. So the case 1 function, we're setting a new variable called unemployment HTML, so high, medium, low. I'm going to show here. So we have our case 1 state function, and if the unemployment percent is less than the 33rd percentile, it's set as low. This is another really useful function. I don't know if it's dplyr based or not. The between function. So if you go back to here, I have a value greater than or equal to 5 and a value less than or equal to 10. Another way to write that exact same structure would be to put between. So the between function, the first argument would be what we are using. So what it's greater than or less than. In this case, it's going to be the unemployment percent. If we have the percent unemployment, if it is greater than, and this would be what you would use. So if it's greater than this 33rd percentile and also less than this 5.0, so anything between those two values will be put as medium. Down here, we're seeing that anything greater than that 66th percentile will be marked high. This is what I was showing before. So I'm going to run this and show you that it does work. So if all of these are not, if all of these are false, it's going to default to this true value. And just so I can show you what's going on here, I'm going to copy and paste here and comment this out. And then instead put just an NA variable here to show you what error it throws. And I forget this a lot. So when I see this, I now know what it means. So all of our values are character variables here. And I didn't set the NA value to be a character variable. So then it throws this error. Must be a character vector, not a logical vector. characters. This is logical by default, so we have to change it to as character. And I want to show you one other thing regarding that. So we go in here. I'm going to open this data set real quick. So in this case, I'm hoping I had NA values in here. Yes, I did. So if you go to the bottom, we're seeing one thing to note is that sometimes when you would set NA to a character variable, you might expect it to actually be a character value or string value, but in this case in dplyr, it is actually set. The type is just character, so it will work just like any other NA value that you've ever seen. So that's what it would look like. And then in this case, Hawaii, sometimes a certain island is included. In this case, it was included in the census data, but it was not included in the unemployment data. So that's why it is missing. It's so small that in some cases people people who collect data, in this case, I believe it's the Bureau of Labor Statistics, they don't collect that small island. So I'm going to change this back to what it should be, which is this as character. Now we'll try it. It runs, of course. So I'm going to show you what. After you do something like this, you always want to check to make sure it worked, because you can see this is complicated. So in this case, the table function, we have our unemployment HML. You see they're not 3 equal groups, but we would expect that because the unemployment variable, if we go down here, it is only 1 decimal point out. So the way that the Bureau of Labor Statistics, they report this is it has always has 1 decimal point. So say we sort by that, you'll see that there's a lot of ties here because it only goes out to 1 decimal point. So that's why you're seeing that the high and medium and low are not equal groups, but it's close enough that you know you did it right, versus this HL or high low for our food stamps is now they are also close, but again, and there's going to be ties. Is there a question?
Yeah. So in that table that you created with the high, medium, and low, does it not show the case where you had an NA as well?
No, so, the table function doesn't.
Okay.
Just by default, it does not show NAs.
Okay, because you're saying that so if we weren't to include the NA, like in the case when, like we would have just, we wouldn't have realized like, hey, in our data somewhere there's an NA value, and it doesn't seem like the table is going to tell us that either.
No, so you would have to use another function. Oh,